Did you know that an open-source AI can now read thousands of pages, compress them into 100 visual tokens, and still retain nearly all the information? Or that Google just taught an AI to spot cancer mutations by turning DNA into pictures? And yes, Kohler, the luxury bathroom company, just launched a smart toilet that literally analyzes what you flush. Today, we're looking at a week where DeepSeek, Shang Shu, Google Research, and Kohler all dropped breakthroughs that show how far AI has come. From reading your data, to reading your DNA, and even your digestion. Let's unpack the madness. So first up, DeepSeek OCR, the new open-source model that just went viral on GitHub. Within 24 hours of launch, it racked up over 4,000 stars, and for good reason. The model takes a 1,000-word article and compresses it into roughly 100 visual tokens, while keeping about 97% of the information intact. That's revolutionary. Traditionally, AI language models consume text token by token, which means the more words, the higher the token tax. DeepSeek flips that logic entirely. Instead of feeding piles of text, it renders the text as images, runs those images through a vision encoder, and gives the language model a short, dense stream of visual tokens. In plain English, it turns words into pictures, and then compresses those pictures into meaning. And this efficiency isn't theoretical. DeepSeek claims that a single NVIDIA A100 GPU can process roughly 200,000 pages per day. That's the kind of throughput data engineering teams dream about. Whether you're building retrieval-augmented generation datasets, compliance archives, or massive pre-training corpora. The model ships open source on Hugging Face and GitHub under DeepSeek AAAI DeepSeek OCR, complete with runnable code, GPU helpers, and VLM acceleration tips. Here's how the architecture works. A 380 million parameter vision encoder generates compact visual tokens. Those feed into a mixture of experts' language model with around 3 billion parameters, though only 570 million are active at a time, which means sparse activation keeps compute lean while performance stays high. And the benchmarks are jaw-dropping. On OmniDoc Bench, DeepSeek OCR beats Google's Goo OCR 2.0, which needs about 256 tokens per page, while DeepSeek pulls it off with around 100 vision tokens. MinerU 2.0, by comparison, often exceeds 6,000 tokens per dense document, whereas DeepSeek stays under 800. Do the math. That's roughly 61% fewer tokens than Goo OCR 2.0 and about 87% fewer than MinerU in similar conditions. And if you're working with equations, dense PDFs, or chemical diagrams, DeepSeek also tops the Fox benchmark, maintaining clarity where older OCRs crumble. Its training data? Massive. Roughly 30 million PDF pages across 100 languages, with 25 million from English and Chinese alone, plus 10 million synthetic diagrams, 5 million chemical formulas, and 1 million geometric figures. The output modes are flexible too: plain text, preserved layout, or image-based summaries. Andrei Karpathy, yes, that Karpathy, called it a computer vision system masquerading as a language model. He says feeding images instead of text simplifies everything. No Unicode bugs, fewer security holes, no byte-level chaos. NYU's Boo Singh agreed, saying it's proof that vision and language can finally share the same highway. Now, not everyone's convinced. Some US researchers have questioned DeepSeek's cost claims from past work. But here's what really matters. A 7 to 20x token reduction means smaller context windows, lower compute bills, and faster RAG systems. For any company paying OpenAI or Anthropic token costs, that's the kind of innovation your CFO actually smiles about. Next up, Shang Shu's VidU Q2, the latest video generation model taking on Google's VidU 3.1 and OpenAI's Sora. Think of it as turning reference video from an experiment into a dial. You can now upload up to 7 reference images, faces, props, scenes, mix them with a text prompt, and VidU keeps every element consistent across the entire clip. It even handles scene transitions using just a first and last frame, letting editors control narrative flow without re-prompting frame by frame. There's an API from day one, which means studios can plug it straight into asset managers and content pipelines. No more babysitting a web UI. VidU Q2 fused all of that, the battery, robot logo, Chinese text, into one clean shot, frame to frame. Google's VidU 3.1 broke the text rendering, and Sora 2 even swapped the Science logo for Nissan. That kind of reliability with logos and non-Latin scripts is a huge deal for brands and global campaigns. VidU nailed both lip syncs and facial expressions across languages. With VidU Q2's multi-entity consistency and fast API, it's clearly targeting creative teams who need control, not just viral chaos. Now, for something life-changing, Google Research, working with UC Santa Cruz, just built an AI system called Deep Somatic, a model that spots cancer mutations by turning DNA into images. If you're thinking, wait, didn't we already sequence genomes? Yes, but this AI goes deeper. It detects tiny genetic changes called single nucleotide variants and small insertions or deletions, mutations that can determine how a tumor grows or resists treatment. A convolutional neural network then analyzes patterns the way a vision model analyzes photos, filtering out noise and flagging mutations that traditional tools miss. And it works across platforms: Illumina, PacBio, and Oxford Nanopore. No retraining required. They trained it on a dataset called CASL, 6 paired tumor and normal cell lines sequenced on all 3 systems. The results? Wild. On Illumina, Deep Somatic hit about 90% F1 for indels, while the next best tool barely cleared 80. On PacBio, it hit 80% versus 50% for others, a massive jump in accuracy. It even found 10 new variants in pediatric leukemia that other models completely missed, and identified mutation drivers in glioblastoma, one of the deadliest brain cancers, in cases where no clean samples were available. For labs, that means 1 model, 3 platforms, better accuracy, and faster results. And for patients, it could mean earlier detection and more personalized therapy. In a world where AI is often criticized for creating fake images, this is one case where turning data into pictures can literally save lives. And finally, yes, this one's real, Kohler's Dakota smart toilet. It features a built-in camera and AI that analyzes your waste for hydration levels, gut health, and early warning signs like blood traces. Price tag: $599 plus a subscription from $70 to $156 per year. Pre-orders are already open, with shipments starting October 21st, 2025. Now, before you laugh this off, it's actually part of a bigger trend: home fixtures that quietly monitor health in the background. Here's how it works. The device mounts over most toilet rims, 32 to 58 mm wide, with a camera pointing down inside the bowl. Kohler calls the optics discrete, since the field of view is limited only to the contents, not the user or bathroom. For multi-user homes, it has fingerprint profiles and end-to-end encrypted data. Take a look.
Introducing Dakota by Kohler Health, a first-of-its-kind product that illuminates your path to better living. Dakota translates your body's signals into real-time insights, helping you decode your body's cues. Focusing on pattern detection for gut health and hydration, Dakota uses advanced spectroscopy sensors to seamlessly analyze what your body leaves behind. Its sleek, self-clamping design blends seamlessly into any bathroom, while privacy-first features like remote fingerprint authentication and end-to-end encryption are designed to keep your data secure. Paired with the Kohler Health app, Dakota delivers personalized health scores to help build lasting, healthy habits. It's everything your body's been trying to tell you, decoded. The future of health starts here with Dakota.
Yes, privacy concerns are real, but Kohler's leaning on on-device processing and restricted optics to keep data safe. So, in 1 week, we saw AI compress language beyond human efficiency, generate cinematic videos in seconds, detect microscopic mutations, and turn bathrooms into labs. The line between software, biology, and everyday life is blurring fast. And the next wave of AI is less about thinking machines and more about sensing ones. Until next time, stay curious, stay inspired, and see you in the next one.